A team I worked with replaced a boring review loop with a beautiful agent graph. Same input, same model most of the time, same final answer. But now every run had node state, edge retries, routing logs, partial failures, and 3 places to mishandle timeout. Their cloud bill jumped, but the worst cost was debugging. One bad summary got blamed on the writer, then the router, then the verifier. The graph did not improve the work. It hid the work. That is the mistake we are killing today. The naive move is to see a messy workflow and say, let's make it agentic. Then the next move is, let's draw it as a graph. It feels mature. It gives you boxes and arrows. It gives a demo something to show. But reliability does not come from having more boxes. Reliability comes from knowing who owns state, who can retry, who can say stop, and how you prove the output is good enough. Most workflows are not actually branching workflows. They are a sequence: draft, check, revise, verify, ship. If every step uses the same context, the same model class, and the same ordering, a graph is usually ceremony with extra blast radius. Here is my opinionated rule. Default to the single loop. A graph has to earn its place. It earns it for one of 4 reasons. First, genuine specialties. Different nodes do different kinds of work, with different prompts, tools, state, and acceptance tests. Second, real parallel fanout. You can run independent branches at the same time and merge results cleanly. Third, per-step model choice. One step needs a cheap classifier, another needs a strong reasoner, another needs a deterministic parser. Fourth, auditable routing. You need to prove why a case went down a path. If none of those are true, do not use a graph. Mechanically, I run this as a gate before design starts. Write the workflow as a plain loop first: input, working state, next action, verifier, stop condition. Then test each graph reason. Specialties means the node would have its own contract, not just a renamed prompt. Fanout means branches can run without sharing fragile mutable state. Per-step model choice means the cost, latency, or capability difference is large enough to justify orchestration. Auditable routing means someone may ask, later, why this item went to legal review, human review, or a stronger model. If you cannot write one sentence for the reason, the graph is not justified. From my own shop, our content pipeline shipped daily for months as a scripted loop. It pulled notes, made an outline, drafted sections, checked banned phrasing, tightened the opener, and produced the packaging fields. It was not glamorous. It had clear logs, one retry budget, and one stop condition. Either the package passed checks, or it went to a human. We did not start with a graph. The graph arrived only when cross-model review became a real requirement. One model wrote, another model challenged claims, and a third pass checked structure and formatting. That was per-step model choice plus a real review specialty. At that point, boxes and routing were useful. Even justified graphs fail in boring ways. The most common is fake specialties, 5 nodes that are really the same worker with different labels. Next is shared state racing, where 2 branches update the same record and the later write silently wins. Merge steps also lie. They sound simple until 2 branches disagree and the merger averages them into nonsense. Routing drift is another one. A classifier changes behavior after prompt edits, and cases start landing in the wrong path. A graph reduces some complexity by isolating work, but it adds orchestration complexity. You still need budgets, typed state, node contracts, and verification after every dangerous merge. This sits in the graphs tier because graphs are not the next level after loops. They are a tool for specific pressure. Earlier in loop engineering, we covered stop conditions, verification, state, and retry budgets. Those do not disappear when you add nodes. They become more important. Each node needs its own input contract, output contract, timeout, retry policy, and failure mode. Each edge needs a reason to exist. Each merge needs a verifier. If your single loop is not observable, a graph will not save it. It will give you 9 smaller places to be confused, instead of 1 larger one. Take one automation you run or want to build. Spend 10 minutes on this. First, describe it as a single loop in 5 lines: state, action, check, revise, stop. Second, list every proposed agent or graph node. Third, next to each node, mark one of the 4 reasons: specialty, fan out, model choice, or audit. Be strict. If a node has no reason, delete it or fold it into the loop. If the only reason is it feels cleaner, that is not enough. Clean diagrams do not carry pagers. Clear ownership carries pagers. 3 beats to keep. 1. The default answers stay in the single loop. It is cheaper, easier to test, and easier to stop. 2. A graph earns its cost through genuine specialties, real parallelism, per-step model choice, or auditable routing. 3. If no reason on that list applies, you do not have a graph problem. You have a loop design problem. This is loop engineering, building agent systems that finish, verify, and stop. New episode daily on this channel, moving from foundations to fleet scale without pretending extra orchestration is free.